Very good morning, friends. Myself, Dr. M.H. Annaya, and in today's video on the subject machine design, we are going to work out a problem on the impact studies when a load falls on the pre-end of a cantilever and the dimensions of the cantilever are given. And the question for today's video reads like this. A cantilever of length 1.2 meter with rectangular cross section. They are given the cross section of the beam and also the length of the beam. Is stuck at its free end by a load of 1000 Newton falling through a height. So we will write down the sketch as per the dimensions given. So we have a cantilever, and this cantilever is of rectangular cross section. There is a load, we'll call this as W, which is falling through a height of, that is height of 20 mm at its free end. This is the distance, and the load is given to be 1000 Newton. And here we have got the member as a cantilever, and the cross section of this beam, cross section is given as, we can represent as B and D. B is the width, and that is given to be a 100 mm, sorry 50 mm. B is 50 and depth of the beam is 150. B and D. The cross section of the beam is also given, and taking E is equal to 200 GPa. They are asking us to find out the stress due to static load, stress due to maximum, that is maximum bending stress, the impact factor, and so on. Friends, here this is the case of a beam that is subjected to an impact load W falling through a height of so and so at the free end. And here the length of this is given to be 1.2 meter, means 1200 millimeter is the length of the beam. So this is the beam you have got here, and this is the load acting at the free end. So since this is a case of bending, if you refer to impact strength in machine design data handbook, you have a formula to find out what is the stress, that is the stress due to impact load, and that is given by the formula maximum stress sigma B dash is equal to sigma B multiplied by 1 plus square root of 1 plus 2h by y. This is the equation available in machine design handbook. Friends, let us find out what are these. Friends, we have sigma B dash is the maximum bending stress. Sigma B is the bending stress due to static load. Then h is the height of drop. Y is the deflection due to the static load. So friends, here we have to find out 1, 2 and 3 because the value of h is given to us. So friends, let us calculate these values one by one. So here friends, sigma B is the bending stress due to static load, due to static load. So this bending stress is given by MB by ZB. The regular formula, the fundamental formula is MB by ZB. What is MB? MB is the bending moment on the member, that is the cantilever. And here for a cantilever beam or a cantilever, comma, MB is equal to W into L, the load acting here at the pre end of the beam into length. This load is given to be 1000 and the length of the beam is 1200. So this works out to 12 into 10 to the power of 5 Newton mm is the value of MB. Then what is ZB? Friends, ZB is called the section modulus, that is I by C. For a rectangular beam, I is equal to B dq by 12, comma, C is equal to depth by 2. So if you simplify this, friends, you get B dq by 12 divided by d by 2 or 2 by d. That works out to be d square by 6. We have the value of b, which is 50. Depth is equal to 150 square divided by 6. You will be able to arrive at this value. Friends, you know the value of MB, you know the value of ZB. If you divide one by the other, you are going to get the bending stress in the member. Friends, after simplification, this bending stress works out to 6.4. That is 6.4 Newton per mm square is the bending stress. And this is the answer for the second part of the question. Next, friends, to find the value of this y, let's see what is the value of y, because only if you know this y and sigma b, you will be able to find out sigma b dash, that is the maximum bending stress. Hence, friends, y is the deflection due to static load, deflection due to static load. Friends, for the case of a cantilever, this is given by WL cube by 3EI. This is available in MDH. The machine design handbook. You will be having this formula y is equal to WL cube by 3EI. Friends, let's substitute the value. The value of W is 1000, length is 1200 cube, divided by 3. Young's modulus is E, that is 200 GPa, which when converted to MPa becomes 220 to the power of 3. I value you have calculated already. Friends, if you substitute these values, you will get the value as 0.2048. The value is 0.2048. That is y is equal to 0.2048 millimeter. Friends, we know the value of y. We have calculated sigma b, and if you substitute in the formula, you will get the sigma b dash, the maximum bending stress. The value of sigma b is 6.4 multiplied by 1 plus square root of 1 plus 2 times h is 20 mm, the height of fall, divided by y value you have calculated as 0.2048. 0.2048. Friends, if you simplify this, you get the value of sigma b dash, that is the maximum bending stress in the member, as 96.07 MPa. 96.07 Newton per mm square or MPa. So friends, you have calculated the value of sigma b dash, the maximum bending stress in the member. We have calculated what is the stress due to static load, that is sigma b, and y, the static deflection also we have calculated. And friends, in the last part of the question, we have been asked to find out what is the impact factor. Friends, you know, impact factor is the ratio of impact factor is the ratio of the maximum stress, that is sigma b max, divided by stress due to, that is sigma b. stress due to the static load. You divide one by the other, that is the maximum value, that is 96.07. You have calculated as the maximum value of the bending stress and the nominal stress, or that is the stress due to the static load is 6.4. And friends, if you simplify, this factor works out to a value of 15.01. 15.01. So what's the meaning of this impact factor 15.01? That is the maximum stress induced in the member due to the load falling through the tide, due to that impact load, is 15 times more than that stress caused due to the static load. That's the meaning of this impact factor. Friends, we are left with the last part, that is maximum deflection. Friends, we have a similar formula to find out the maximum deflection, and that's given by y max is equal to y multiplied by 1 plus square root of 1 plus 2h by y. So friends, y we have calculated as 0.2048 multiplied by 1 plus square root of 1 plus 2 times 20, 2 times height, divided by the value of y is 0.2048. Friends, if you simplify this, you get this answer as 14.22. So maximum deflection is 14.22 millimeter, and the deflection due to the static load is 0.2048. Friends, I hope the presentation was interesting. Please go through the complete video, and if you find this useful, please share this information with all your friends. Have a blessed day. Thank you very much.